Hello friends, in the previous video we have already discussed the translation motion of a particle in a one-dimensional box. There we have discussed how the wave function of such a particle can be described, what is the Schrodinger equation, what is the energy expression for such a particle. Now in this video we are going to discuss about the translational motion of a particle inside 2D and a 3D box. In this here also we are going to all those things for 2D and 3D box. So without further delay, let's start with our topic. So first started with the two-dimensional box. In two-dimensional box, we consider the two Cartesian coordinate, that is x and y, in order to describe the box. Along the x-axis, dimension of the box is supposed to be a, and along the y-axis it is considered as b. So box is supposed to be like this. This is the two-dimensional box, and a particle inside the box which is freely allowed to move along x and y directions. Here also some boundary conditions is imposed to describe the motion of such particle. Inside the box, what is the boundary condition? Inside the box, the potential energy is 0, and outside the box it is infinity, and psi is finite, that is the wave function, it is finite inside the box only, and outside the box it is 0. This kind of boundary condition we have imposed for such motions. So wave function of such particle, to describe such translational motion of a particle in quantum mechanics, it depends upon two variables, that is x and y. That is, wave function is a function of two variables, that is x and y. Okay, so Schrodinger equation for such particle we can written as Schrodinger equation. We can write it as dy square psi xy and d square divided by dx square psi xy 8 pi square m divided by h square e into psi xy equal to 0. So this is the Schrodinger equation for such particle. This is we know that this is a second order differential equation, and solution is very complicated, and on solving this equation we got the solution for psi, which is a function of xy, and it is equal to the product of two functions x and y, which is equal to root over 2 by a, where a is the dimension of the box along x-axis, and sine n pi by a into x into 2 by b sine n pi by b into y. So this is the function of y, and this is the function of a x. So this is the wave function to describe such kind of a quantum mechanical system. We can also find the energy expression for such system, which is equal to the nx square. This is the quantum number along x direction, h square 8 ma square plus ny square h square divided by 8 mb square. If the dimensions of the two-dimensional box is equal, that is a equal to b, then we can write the expression for E as h square divided by a square and x square and y square. So this is the expression for E. These two things you should know for two-dimensional box. Now we are going to discuss about three-dimensional box. In three-dimensional box, here three coordinates, there are three directions, that is x, y and z. These three conditions, these three coordinates, Cartesian coordinates, are considered, and the psi, the wave function, is also a function of these three coordinates. So the box will be something like this. It is something like a cube. So it is x direction, it is y direction, so this direction is z direction. Dimension along x is a, along b it is b, along y it is b, along z it is c. So dimensions are a, b and c. These are the dimensions of the box. Here also we consider some boundary conditions. What are the boundary conditions? That is, inside the box the potential energy is 0 and psi is finite, and outside the box psi is infinitive and psi is V is infinitive, that is potential energy is infinitive and psi is 0. These two things is considered. Okay. Now the Schrodinger equation for such system can be written as Schrodinger equation. So what will be the Schrodinger equation? This will be d square by dx square psi x, y and z. Psi is a function of three variable x, y, z. D square divided by dy square psi x, y and z. D square divided by dz square psi x, y and z. And 8 pi square m divided by h square e psi x, y, z equal to 0. So this is the Schrodinger equation. On solving, root of the equation will be psi, which is a function of x, y and z. This will be the product of three functions: x, which is a y, which depend upon y, and z. Okay, and this can be written as root over 2 by a sine pi by a into x, root over 2 by b sine and pi by b into y, and root over 2 by c sine and pi by c into z. So this is the wave functions, required wave functions for the system. And the energy expression will be, if all the energy expression will be somewhat like this: ma square and y square h square 8 mb square and z square h square divided by 8 mc square. If this a, b, c are equal, then we can write h square divided by 8 ma square into nx square and y square and z square. So this is the energy expression for a particle, translation and motion of a particle inside the three-dimensional box. So if you know these things for two-dimensional and three-dimensional box, then you can easily solve the questions from two-dimensional and three-dimensional box. Okay, so in the next video we are going to discuss about the degeneracy of energy state for two-dimensional and three-dimensional box. So guys, if you have any doubt, please let me know in the comment section below, and subscribe our channels for more videos on chemistry based on CSIRnet and GATE as well, and press the bell icon for instant notification. Thank you.